In this video, I'm going to go over the assignment for 0406. And I always say start by going to your grade report, as this is the easiest way to see kind of your grade, your progress, and just what all the assignments are. I'm going to come down here to 0406, evaluating data. And yours should not say this. Mine's a little bit different. And down here are my directions. So you must make a copy of this template and then download it as a PDF. Please make sure you're downloading this as a PDF as it messes everything up when it's not. We'll click this link and then we'll come back here and submit your PDF as an attachment. Links or other files will not be accepted. So I'm going to open this in a new tab so it's easy for me to come back here. And this should tell you to make a copy, to make your own copy. If you don't have access, just ask for access and I can get that to you. So this is the template for 0406, evaluating data. Again, when you're finished, you must download this document as a PDF and attach it as the submission. And the way that I do that is I just go to File, Download, and here's PDF right over here. All right, you want to start by just typing your name in here, type in your period, and let's get into the project. So this says, suppose a golf club company has designed a new club, which it claims will allow a professional golfer to make a hole-in-one 20% of the time, and an amateur golfer 10% of the time. Professional and amateur golfers sign up to play 5 games of 18 holes each. And I've kind of helped you out here, making just a little chart for each of the 5 games, and each of these are going to have 18 holes of golf. So part A says design and conduct a simulation to estimate the likelihood that the professional golfer will sink at least 4 holes in one during a single game, at least 4. Be sure to explain the representations and show all the work. All right, so let's start by just coming in here, and what we want to find is what is the probability that X is greater than or equal to 4. What is the probability of that? And here, this is where X equals the number of holes in one in a game. There we go. And again, please don't type exactly what I'm writing here. Make sure that you put this into your own words so it's not flagging you for the turn it in or anything like that. So what we're going to do, this is going to be, we're going to say P for probability. This is going to equal 0.20 for this. And what we're going to do is we're going to use this table of random numbers. I'm going to open this again in a new tab. This will generate our random 2-digit numbers for each game, which is what we're going to do here. So we're going to say we're going to use 00 to 99 using these values. There we go. So using these two-digit values, this is going to give us 100 numbers, but again, we'll be staying within 2 digits, which will make this easier for us as we get into the table of random numbers. Or if you're using a random number generator, this will be a little bit easier for you. And we could say that the values from 00 to 19, so those first 20 values from 0 to 19, these are going to represent a hole in one. All right, and we will use this we'll use this to generate 5 games. Of 18 holes each. So that's what I've set this up for you over here in the table. We have 5 games, again, with 18 holes each. And we'll also record how many times a hole-in-one is scored. All right, so again, make sure you're not just copying this. Make sure you write this in your own words. I'm going to open this table of random numbers in a new tab. And the best way to do this is to, again, use that split screen view where I've got one open over here and this open over here. And for the table of random numbers, I want to start by saying the biggest misconception with this is thinking that these are all 5-digit numbers. So here the spacing is just to help us so that we don't get lost in the sea of numbers. These aren't 5-digit numbers. It's really, you could think of this as just one long, gigantic run-on sentence of numbers. But the spacing is just here to help us kind of keep track. And what I'm going to do is I'm just going to pick a random starting place. So I'm going to start here. I like the way this one looks. Or you could start with, the first line, second line. Probably a lot of people are going to start with the first line. So I would say just pick a different line here to start with. So I'm going to start with this one. And I'm just going to start writing these numbers into my chart over here. So I've got 7, 8 is my first random number. Next, I've got 4, 3. Next, I've got 5, 3. And this is going to take a little bit of time here. It does get a little tedious. Okay, so I sped that up because I'm sure you don't want to sit there and watch me type in all these numbers, but I just wanted to show you how I was getting them. And again, these are random numbers. We should all have different randomly generated numbers for this. So my next step is I want to total up how many holes in one for each game. And again, remember that we defined this as values from 0, 0 to 19. So let's start with game one. I'm looking for anything that's really under 19. And I'll bold that. So I've got 0, 7, 0, 1, 17. I think that's all that I see. All right, so we've got 1, 2, 3. My total here would be 3. We just got 3 holes in one for that first game. For the next one, so here I see this is less than 20. This is less than 20. All right, so again, I see 1, 2, 3, 4 for this one. For game 3, again, I'm looking for numbers less than 20. Here's 18, 16, 0, 4, 15, 13. So I've got 1, 2, 3, 4. Let me count those again. 1, 2, 3, 4, 5. I see 5 there. Same thing with game 4. Here, this is less than 20. 0, 1, less than 20. 0, 6. 17. And I think that's it. So I've got 1, 2, 3, 4 for that one. And then my last one, game 5. So here's 0, 4. That's less than 20. 15. 0, 8. And I think that's it. So here I've got 1, 2, 3. Okay, so these were the total holes in one for each game. And remember, I'm trying to figure out what was the probability that X was greater than 4. Greater than or equal to 4. So if I look here, it's not going to be 3. It would be 4, 5, and 4. So it looks like we had 3 games that were greater than or equal to 4. So for this, let's just say the probability of x being greater than or equal to 4, that was 3 out of 5 times. And if I divide that on my calculator, I get 0.6, which is just 60%. All right. So again, with this first question, it is kind of tedious getting those random numbers. We should all have different numbers for this because it is random. And then don't forget to write this in your own words. Part B is kind of similar. Here we're going to design and conduct a simulation to estimate the likelihood that the amateur golfer will sink at least 4 holes in one during a single game. And again, be sure to explain the representations and show all work for your trials and outcomes. So again, we're going to use that table of random numbers, but this one will be a little bit different. So here we're trying to find the probability that x is greater than or equal to 4. And this is, again, x is the number of holes in one in a single game. And for this one, our p equals 0.10. For this one, this comes back to the question up here. So our last one was 20% for the professional golfer, and this one was 10% for the amateur golfer. So kind of similar to before, we are going to use these values 00 to 99. So again, we want to use these two-digit numbers to make that easier. And we'll assign the values 0 through 9. Because again, we're looking at 10% probability. We're going to use these first 10 numbers. And we could say that these two represent a hole in one. All right, and we will use the numbers 10 through 99. These will represent not hitting a hole in one. Again, we want to, we'll say again, we want to generate 5 games of 18 holes, which again, I've made that table for you over here, 5 games of 18 holes, and we'll record how many times we get a hole in one. All right, so again, I'm going to use that table of random numbers. So again, I sped that up for us because I'm sure you don't want to watch me sit here and type all these numbers in. But again, these are randomly generated numbers from that random number table. And we should all have different numbers for this, just to remind you. So my next step here is I want to count up all the numbers that are less than 10. Or I would say 00 to 09. So coming down here, I've got 04. And that's the only one that I see. So just 1. Here I've got 07, 02, 0, 4. So I've got 3 as my total. Here I've got 0, 4, 0, 7, 0, 6, 0, 2, 0, 5, and I think that's it. So this one, 1, 2, 3, 4, 5 total for that one. And game 4, I've got 0, 1, 0, 4. I think that's it. I just see 2. And the last one, game 5, here I just see 0, 3. I'm just bolding these, or you could highlight them too. And 0, 6. I think that's it. All right, so a total of 2 for that one. All right, so that is pretty much it. What was the probability that x was greater or equal to 4? So I just see really just this 5 was the only one that I see there. So this would be 1 out of 5 games. And if I divide that on my calculator, I get 0.2, or you could say 20% for that one. All right, coming down to part C, this said design a study to test the new golf club to see if it causes amateur golfers to perform better than with the currently used club. Remember to give enough detail that your study can be replicated. So for this one, the first 2 parts, part A and part B, we simulated an experiment. For this, they're asking you, how would you design an actual study? So remember to start with a good study. A good study starts with randomly assigning. Here I would randomly assign, maybe 50 amateur golfers to the new club and 50 to the old club. From here, I would remove all the labeling. I want to make sure that this is a double blind test. So I'm making sure that they don't know which clubs they're getting. And I also want to make sure that I don't know which clubs they're getting. I want this to be double blind. Let me write that in here. So I'm not writing all of this down because, again, I don't want you to just write what I'm writing or just write what I'm saying. So again, put this into your own words. I would remove all the labeling to make sure that it's a double blind test. And then we could have each golfer play an 18-hole round of golf at an assigned golf course. I would make sure that they are assigned to the golf course. We don't let them pick the one that they want to do. And then from there, we could just record the number of holes in one. So something like that, something where you are designing an experiment. But again, I'll say in your own words. So I'm not going to write what I said in there. So moving down to part D, we're almost finished here. Suppose a study was conducted using professional golfers and found the following data. So here's our data. Holes in one with the old club was 30. Out of total swings tested was 200. And for the new club, we had 55 holes in one out of 225 total swings tested. And they're asking us to construct and interpret a 90% confidence interval for the data, and what conclusions can we draw? So here, they are getting kind of ahead of us. So I'm giving you the formula for this. I said, hint, use this formula. And z-score, we haven't really talked about this yet either. This is coming in a later module. So for now, all you really need to know is that our z-score for a 90% confidence interval, we're just going to use this number. I'll show you how we get this number, but that's in a later module. So all I'm going to do is double click to show my work in this box, and I can delete that. The first thing I want to do is calculate my p-hat. That stands for sample proportion, and I'm just dividing 30 divided by 200. I get 0.15. So I could say P hat for the old club is equal to 0.15. And I'll do the same thing for the new clubs. Also, for the new clubs, I'm dividing 55 divided by 225. And here we can round that. We could just say 0.24. So here I get P hat equals 0.24 for that one. It's kind of hard to write in here, so you could also use the text tool and just type this out as well. So we'll say this is old and this one's new. So I'm just going to plug these numbers in to that formula. All right. So P hat's going to be, for the old one, is 0.15 plus or minus the z-score, which we're going to use 1.645. Again, I'll show you how we got that number in a later module, but for now we just need that number. This is times the square root of 0.15 times 1 minus 0.15. All right, and that's all over n, which is the sample size. Here it's 200. All right, and we will do a similar thing for the new club. So over here I would do 0.24 plus or minus 1.645. And this is times the square root of 0.24 times 1 minus 0.24. And this is all over n. The sample size here was 225. All right, so that's kind of the hard part, is setting up our formula. From here, you're really just doing some PEMDAS on your calculator. First, I want to do 1 minus 0.15 times 0.15. Divide that by 200. And then I square root it. And then I multiply times 1.645. So that's some PEMDAS steps there on your calculator. For that, I'm getting 0.15 plus or minus 0.042. And that just means add these numbers and also subtract these numbers. So if I do 0.15 plus 0.042, there I get 0.192. And also, if I subtract, if I do 0.15 minus 0.042, there I get 0.108. So that's going to be my numbers down here. So we would say we would say 0.108, comma 0.192. And now for this, we should all get the same numbers for this. We will do the same thing with the new clubs as well. So here I'm doing PEMDAS. I do 1 minus 0.24 times 0.24 divided by 225, square root that, and then times that times 1.645. So here I'm getting 0.24 plus or minus 0.047 for that one. So again, I'm going to add these numbers and subtract these numbers. On my calculator, I'm getting 0.193 and 0.287. All right, so notice these are our two intervals here. These are our two intervals, and notice they don't interlap, right? Or they don't overlap. This one goes up to 0.192. This one starts at 0.193, so there is no overlap with these. We could say that the new golf club is better, all right? So that's going to be my last thing down here. I'll just write, since there is no overlap. I'm not going to write the whole thing out. but we could say the new golf club is better. And our last part is part E. Can you say the new golf clubs caused the professional golfers to improve their performance, and explain your reasoning? So this one is, you could say yes, you could say no. It depends on how you feel about this experiment. So did we have a controlled experiment? Was it well designed? Again, you could say yes, you could say no. You have to explain that. Give me just 1 or 2 sentences, again, in your own words here. All right. So that's pretty much it. Your last step for this is you just want to go to File, Download. Download this as a PDF and attach that back here to your assignment. You'll just go to Choose File and then choose that PDF that you just made. All right, this is a very tough assignment. I hope that this video helped you out, and good luck with your course.